Well, hello to everyone. My name is Paulo Mogollon. I'm from Colombia, and okay. So I'll be presenting on how we at Propiedata scaled, uh, like the first steps on scaling Meteor. Um, so yeah, let's start. Um, Well, a little bit of my background. I'm a full stack developer. I started with Meteor or developing with Meteor in 2016 with a personal project for a startup I was starting. And I fell in love with it. I came from a PHP and jQuery and MySQL background. And when I started with JavaScript and Meteor specifically, I just fell in love because of the fast pace of development with it. Um, so I have a experience with PHP, MySQL, Mongo, Meteor, Node, jQuery, Java for mobile apps, and Objective-C and Swift. Mm, well, after that first startup, that went broke, uh, and after that, I started working on another startups in Israel and Silicon Valley, and after that, I came back to Colombia and started a company called Propiedata. And in Propiedata in 2019, we started doing property management, software for property management. It was a very like simple platform. It just like everything in forms, lists, dashboards, and mainly cron jobs for how to say like notifications, emails, and yeah, just tasks in general. And in 2020, we realized that there was an opportunity doing assemblies for properties, for companies and other organizations, but virtually. So we developed a platform for this. It's mainly focused on polls and its results, but based on the property coefficient of every shareholder. So if you have 3.5% of a company or a property or something, that it's what your vote counts. And it have other complexities, but that's mainly it. It was also the chat with the reactions, interventions queue, and participation analysis. So in 2020, we started with that. It started growing very fast in Colombia, and we faced a lot of let's say scaling uh, inconveniences or issues, and the platform end up going down like 3 times. But we realized that it was mainly because of poor design choices and issues with mainly with the database and the queries. So uh, in I think it was last year, we had 15,000 concurrent users, and the platform at some moment it just went down. We had like 100 assemblies, and I really realized that we had to do something to start focusing on optimizing what we already had to be able to scale it further. So this is where things get a little bit more interesting. Uh, what we started doing was we started moving all of the heavy jobs out of the main app. So we have it was a completely monolithic app with Meteor. So we started creating a separate app just for the heavy jobs, also in Meteor, in specific servers just for that. So that helped us reducing the load on the main app servers, the user front end servers. It also reduced the method and subscriptions response times, and it made it just more stable and dependable. So it would like a heavy task or a heavy job wouldn't take down a server that was being used by 300 400 users, and that was that helped us a lot. But that was just the first step. The second thing was choose methods over publications or subscriptions. So at start, we had everything or mostly everything over subscriptions, and that's very expensive in the server and the database resources. So we started moving as much as we could to methods. At that point, we started using a that's called Grapher, a package that it's used to like have joins and relationships between collections. So we started using methods a lot and started like shifting or changing the schema of the database. I'm gonna talk about that a little bit ahead. So after that, nothing that was like not all data is required at every time. So another thing that we were failing at, we were not using like the projections in the queries. So in publications, it's better, or in subscriptions, it's better when you limit the fields that you're returning and that you're watching. Also, to limit the amount of um, of documents. And doing subscriptions or publications or real-time data make it much more complex to do complex queries. So you start having reactivity like issues, or making it more hard for the server to respond. So the main thing here is choose methods always over publications when you don't need real-time data. Sorry. So the third thing was optimize the MongoDB queries. So we were not very good at Mongo. We like almost everyone from back, we know a lot of MySQL and relational databases, and shifting to document databases, it's non-relational databases, is a little bit complex at starts. So just starting with the schema of documents, it's we always think about it relationally. So I'm gonna talk about schemas later, but we started doing or creating indexes for our like complex indexes for our queries. At first, we just thought like, yeah, we already have indexes like for fields, but we didn't have compound indexes for our queries. So that's one of the main things for scaling, and it's not just like the index and you already created and use it always, but there's a certain way to create indexes that it's like the most efficient. We're gonna talk it later. Also get only the fields you need, like do projections on every query. Don't bring all the document, just the fields you need. Beware of queries that have an issue that's called n+1. Mainly, it's that imagine you have you have cars and the owners of those cars. So if you bring all the cars, but also you bring all the owners for the cars, and you call the database for every car, you're calling the database 1,001 times for that query. So it's better if you just call you get all cars, and then you get all the owners in just two queries. That's make it easier. It's like very simple, but when you're starting, or when we were starting, uh, that was a big issue, that when you are like creating MVPs and moving fast, you don't see this as an issue that you might have. So this is one of the most important things, apart from indexes and the schema. The fourth thing is check for long running queries, like everything like higher than 100 milliseconds. It's something that you should be checking always. Query that it's taking more than 100 milliseconds, you should be checking. Why? Mainly that's because you're not using an index, or you're not using a complete index. So it's just using using it partially. And one thing that we learned: don't use regex for your queries. The thing is extremely slow, and it has to go through all the documents in a collection to get your result. So if you can, if you're using Atlas or another service, try to use uh, text searches, or full text search from Atlas, that it's much faster, or other things like Elasticsearch or something else, but don't use regex. Well, the fourth uh, main point is use redis oplog. That just mainly reduces the load on the servers. This is something that it's very common already for people in Meteor for real-time data. So when you just use redis oplog, you reduce the load on the servers. You also reduce the load on the database, and you can tune it to listen to specific changes. So when you tune it for channels, you can have even better reducement of load, and only publish changes you need. This package allows you to just push, in some cases, the data or the changes. So if there's some data that you don't need to be reactive, you can just omit it from the changes you are publishing to Redis, and it will load less the service. Well, after Redis, we reduced a lot of our load, but we still had some issues with methods that were loading very slowly, mainly because of security checks that were taking too long. So we started using cache for cache for for those functions or methods, and that helped a lot. Mainly the security parts, because every method call was calling some queries that were a little bit heavy. It's not like 100 milliseconds, but we're taking 15, 20 milliseconds in some cases. But those methods were called 30 times a minute, but by just one user. So that multiplied by 15,000 users at that point was making a lot of queries to the database. So we started catching those queries, or those responses from the methods, and that helped a lot. And also, one of the main things is it will reduce the response times of the methods and the subscriptions where you're making those checks. Um, not just one, but for everyone. And that was something that helped us a lot. We started catching that data locally in the server in memory, but when we were scaling, we had 6 servers, 8 servers. So what we did was we were already using Redis, so we were catching we started catching with redis too. So here comes something that I just learned some days ago. We started using Atlas, I think it was like a year and a half ago, and I think it was last week we had we contracted a consultant from Mongo, and he helped us with some limitations we were having right now with our database, and that's we found out something that I will leave for the last part of this slide, but something he told us is schemas must be thought, or we should think of the schemas on how we will query the data. And one thing that it's very common in non-relational databases, that it's not common at all, and it's not a best practice in relational databases, is that in Mongo or any other non-relational database, we can have duplicate data. So one thing is that you can cache other collection data in a single one. Like, let's have an example with the same cars and the owners. You can, like, depending on how you will query the data, you can have cars with a cache of that owner data that you will query inside the car object in the cars collection, so that you don't look up for that data in another collection and create more queries, or that's just one query with the fields you need, and that's it. That's something that it's like really simple, but when we come from relational databases, we don't think that way. So it's something that we need to change a bit our mind. Not everything should be duplicated around every collection, but when you're thinking about how you will query the data, you can improve your schemas to reflect that of how you would query the data. The other thing is filter and limit your queries as much as you can. All queries should have an index, and every index should be used in a query. Like, just don't create indexes just because they should exist, but every index should be used by queries always, because there's a limit in the amount of indexes that Mongo can handle in a collection. And also, the more indexes you have in a collection, the more it will take when you have an insert, because in each insert, the operation will need to update all the indexes, and that it will make it every time in every index a little bit slower, and the bigger the index is, the slower it will be. Another thing that I don't know what we didn't knew this. There's a rule called the ESR rule. It's equality sort range rule when you're creating indexes, and I will let you leave you this in maybe in the chat or later somewhere with the links. So when you're creating an index, you should put first the fields or the part of the index that it's from equality, like the equal part, or yeah, just equalities, like equal to something. Then the sorts, and then the ranges, like dates, or greater than, lower than, equal, and everything else. So this will make that your indexes will be used in a much efficient way. We didn't knew this. It's on the documentation. I don't know when they added this. I didn't see it when we were starting with Mongo, and it helped us a lot with the queries. The performance was much better when we changed some indexes with this rule. Um, the other thing is that the field that filters the most in a query should be first. Like, let's say with the same example of cars. Like if you have a car has a make, a year, a brand, and a color. Um, there's a lot of colors. There's a lot of like years or make, but maybe your collection just has 5 brands of cars. So if you filter first for brand, you might have just like 20% of the collection. If you filter then for year, you'll have less. So you should filter always the sorry, you should put first the field in the query that filters the most. So in this case, it's not a brand, but maybe year. Bring me all cars that are from the 2020, and then the color and then the make. That also helps reduce the load in the database when you're querying very large collections. And one thing that was our main issue that we learned in I think, the hard way, is that we thought, well, we are not gonna limit the network access, and we will at start we will leave it open because we need access to the database in sometimes when we are out of home, or when we are in or another server that we might need to just launch and have online. But that was having a huge issue that we didn't realize until this consultancy, is that uh, there was maybe just a bot that found our MongoDB URL and was trying or attempting to crack the password and the username. It was not just for security, but every time that bot was trying to authenticate to our database, it was having it was making the server have performance issues, because every time it attempts to authenticate, MongoDB has, I think it's 3 rounds of hashing or 2 rounds of hashing, and it's very heavy on the CPU. And it was like the usage graphs were very high, even when we were not having too much users. So as soon as we just limited the access to our AWS VPC, it just went away, that load, and we managed to get from an M30 to an M10 just by doing that. So this one is the first thing. If you don't already do it, you should. We learned the hard way. So something else that we learned the hard way was to rate limit your methods. Not only because someone can like DOS you with a method that they can call and call and call and call, as very server resources intensive, but because sometimes someone can I don't know, maybe put something. There can be an issue in the code you developed, and it might run 1 and 2 and 3 times and over again, and you might DOS you yourself. So when you rate limit your methods, that handles both an external threat and the threat that an issue can DOS you. So we learned this also the hard way. when you're using collection hooks, in some packages, there's like 2 or 3 packages that uses collection hooks. So collection hooks, in every hook you create, they get the previous document, and that creates another query that you're not aware, because you're not creating it yourself. So you need to be beware of collection hooks because they create additional queries that you might not know about. So this is something to have in mind. One thing that I don't know how to say it, but it's just don't expect every package to fit like a glove. Packages are very general or very for a specific use case, and sometimes it's better if you take that package, and if you see that you can like implement some changes that are just like good for your application, it's okay to do it. And we do this with the grapher, we do this with aligning rows, we do this with I think three more packages that we have local, we have them local, so that we can like do our improvements that are very specific to our application. So that has helped us to scale. Like, don't expect for the maintainers to create something that is very specific to your use case. So it's with Meteor, it's very simple to just put a package in the packages folder and just implement the changes you want. And something that we didn't know is to aggregate data once and save it so that you can query it later. This helps a lot with the queries that are very heavy. We were calling them once and again and again and again. So it was much faster to just aggregate the data once, have those queries, like the data, like we will show it in the UI, stored, and then just show that. It's much faster for the database and for the servers. So after we did all this, we started saving $1,700 a month. We were paying like $2,500 a month, and we managed to reduce it a lot. And sorry, and we are now like paying just $400 for when we have peaks of 15 and even further. It's not like the price or the cost is not scaling linearly with the amount of users. So that's something that helps a lot. So this is a quick recap. Move heavy jobs out of the main app, choose methods over publications, optimize your MongoDB queries, use ready oplog, cache frequently, use data, and think Mongo and not relational. So yeah, that's how we did it. So I'm gonna check it. Oh,
Thank you very much for this amazing talk. I think this has a potential to become the defining talk on how to do scaling.
nice.
That's,
I think there's
there was one question I've kind of already answered from Jonathan Buckland asking, what's the best approach to establish how long a query takes to run with APM? And the answer is yes.
yeah,
APM, like Monty APM, shows
yeah,
you how.
we use Monty for getting the data, but in Atlas, if you use Atlas, You can also check the profiler, and the profiler will show you what's the queries that are taking long, the queries that are not using how you call it, indexes, or queries that are using indexes but just partially. And Atlas, I think it's very complete for this, so I would recommend it a lot. And if you use let me check, I don't remember the name of this, NoSQL Booster, you can also use NoSQL Booster to change the parameter on MongoDB to log the queries that are above a certain amount of milliseconds, and you can just change 50 milliseconds, 100 milliseconds, 200 milliseconds, and after that it just puts it in a collection, and you can just see that, and it will help a lot to identify those.
Awesome. Thank you very much for expanding on that answer.